So this is experiment 16, calculations and graphs, part 3. So let's take a look at the graph that you're making. In part 3, this is the part where you transferred charge to the parallel plate capacitors multiple times, but however, to differentiate this from part 2, you had a plastic dielectric between the two capacitors. So you should graph this out exactly the same as you did in part 2, with voltage in volts on the x-axis and charge in coulombs on the y-axis. And then to look at these calculations, our goal is to figure out what the dielectric constant is. This is going to be a lofty goal that's going to take a lot of calculations. So the ultimate equation we're going to be using is parallel plate capacitor, a dielectric constant K equals the capacitance 1, which is capacitance from part 1, times the voltage when there is not a dielectric minus the voltage when there is a dielectric, plus capacitance from part 2 times the voltage when there is not a dielectric, all of that divided by capacitance from part 2 times the voltage with the dielectric. In theory, all of this should give you about 1.5. Okay, so then to figure out what the voltage is without the dielectric, you then do voltage initial equals the sum of the change in voltages divided by n. N is the number of times that you transferred charge using your little wand from the sphere to the capacitors. So then to get change in voltage, the sum of the change in voltage, you're going to refer back to your graph. Let's look back at this. In this one, we actually have to look at our graph from part 2, because part 2 is where we didn't have any dielectric. So then you're going to do your final point minus the one before it, and that one minus the one before it. And in this case, you're always doing what the voltage is of each of these. And then if you look back at this was final point 9.5 volts minus the one before it, 8 volts, and then sum it all up, plus 8 volts minus 6 volts, plus 6 volts minus 4.5, etc., to get all your points, divided by how many times you actually transferred charge. And then that will give you a number in volts. Yes, and then for the voltage with the dielectric, you have to do the sum of the change in voltage divided by n, exactly the same, but this time using your graph that includes the dielectric, which is the graph you made in part 3. So then if we look back at this, we're doing this point, the voltage at this point minus the voltage at this point, voltage at this point minus the voltage at this one, and adding all of these differences together. So we get final voltage minus the one before that, plus the second to last voltage minus the one before that, etc. All of that divided by how many times you transferred charge. And that'll also give you a number in volts. Now, to pull it all back into the original complicated equation, dielectric constant is equal to capacitance 1, which comes from part 1, which is here. So in my case, it was negative 1.8 times 10 to the negative 11th farads, which is the same I have right here. And then multiply that by your voltage without the dielectric minus your voltage with the dielectric, which in my case was 1.4 volts minus 1 volt, which is what we just calculated. And then add capacitance from part 2, which you literally just refer back to part 2 and see what you got there. in my case it's this number, 7.5 times 10 to the negative 12th farads, and plug that in right here, 7.5 times 10 to the negative 12 farads, multiplied by the voltage when you don't have a dielectric, which in my case 1.4, 1.4. All that divided by the capacitance from part 2 times the voltage when you do have a dielectric. And then all of that will actually give you farads times volts divided by farads times volts, which gives you a unitless number, which theoretically should be 1.5, and if you don't get a number near 1.5, then your lab was not successful. If you are close to 1.5, then it was successful.